Welcome students to my channel. In today's video, we will learn how to multiply two matrices. Like the addition and subtraction operation of two matrices, in case of multiplication also, we have one condition that must be satisfied by the two matrices. Here the condition is number of columns of the first matrix must be equal to the number of rows of the second matrix. For example, if we have two matrix A and B, where the order of matrix A is m cross n and the order of matrix B is n cross p, then if we want to find the product AB, the condition this condition must be satisfied by AB. So in this case we can see the columns of the first matrix. So the first matrix here is A, the number of columns for matrix A is n, and number of rows for matrix for the second matrix, that is B, is n. So both are equal, so in this case AB is defined. We can find the product of AB. But if we want to find the product of BA, so in this case the first matrix is B, so the number of columns for the first matrix is P. Now the second matrix is A, so the number of rows for the second matrix A is M, so P is not equals to M. Hence we cannot find the product of BA. So this condition must be satisfied by the given matrices. Now let us look how to find the product of a 2 cross 2 matrix of two 2 cross 2 matrices. A is a 2 cross 2 matrix has having the elements A11, A12, A21, A22. B is another matrix, another 2 cross 2 matrix having the element B11, B12, B21, and B22. Okay, one more thing we have to specify here. While finding the product of AB, the order of the product matrix or the order of the resultant matrix will be M cross P. Okay, the matrix A has order M cross N and matrix B is of order N cross P. These two are equal, then the order of the product matrix will be M cross P. So this is the rule. The order of the resultant matrix will be the number of rows of the first matrix into number of columns of the second matrix. So here both the matrices is of order 2 cross 2. Number of columns of the second matrix is equal to the number of rows of the number of columns of the first matrix is equal to the number of rows of the second matrix. The condition is satisfied. We can find the product AB, and the matrix AB is of order M cross P. Here M is 2, P is also 2. So this is of order 2 cross 2. Now for a 2 cross 2 matrices we have 4 elements. One is at the 1 1 position, one is at the 1 2 position, one is at the 2 1 position, one is at the 2 2 position. Now while finding the element at the 1 1 position or at the ijth position, we have to consider the ith row of the first matrix. So here I is 1, we have to consider the first row of the first matrix, and the jth column of the second matrix. J is 1 here, so we have to consider this. Now we have to multiply the element and taking their sum. So A11 into its corresponding element is B11 plus A12 into B21. Similarly, while finding the element at the 1/2th position, we have to consider the first row of the first matrix and second column of the second matrix. So A11 into B12 plus A12 into B22. Similarly, for the 2/1th position, we have to consider the second row of the first matrix and first column of the second matrix. So it will be A21 B11 plus A22 B21. Similarly, for the 2/2th position, we have to consider the second row of the first matrix and second column of the second matrix. So it will be A21 B12 plus A22 B22. So this is the product matrix, or this is the resultant matrix. So this is how we have to find the product of the two matrices. Now here we have two matrices of order 3 cross 3. This is of order 3 cross 3. This is of order 3 cross 3. So here also the condition is satisfied because the column of the first matrix is equal to the rows of the second matrix, and the resultant matrix is of order 3 cross 3. So for the 1 1 position, you have to consider this row and this columns. So 0 into 5 is 0, plus 2 into 1 is 2, plus 5 into 5 is 25. Similarly, for this 1/2 position, we have to consider the first row and the second column. 0 into 1 0, plus 2 into 0 0, plus 5 into 2 is 10. Now for the 1 3 position, we have to consider this first row and the third column. So 0 into minus 2 0, plus 2 into 2 4, plus 5 into minus 1, that is 5. Similarly, for the 2 1/8 position, we have to consider the second row, then 1 into 5, that is 5, 2 into 1, that is 2, plus 9 into 5, that is 45. Similarly, for the 2 2 position, you have to consider the second row and the second column of the two matrices. Then it is 1 into 1, 1, plus 2 into 0, 0, plus 9 into 2, that is 18. For the 2 3 position, we have the second row of A and third column of B. So 1 into minus 2 is minus 2, 2 into 2, that is 4, 9 into minus 1, that is 9. For 3 1, we have to consider third row of first matrix, first column of second matrix. 40 plus 4 plus 25. Then 8 plus 0 plus 10. Then minus 16 plus 8 minus 5. Now we have to just add or subtract the elements inside the matrix. So the first element is 27, it is 10, it is minus 1. This is 52, this is 19, this is minus 7, this is 44 plus 25. That means 69, this is 18, and this is minus 8 minus 5 minus 30. So this is the answer, or this is the product of these two matrices. So this is how we have to find the multiplication of the two matrices. That's all for today. If you like this video, please do like, comment, and subscribe my channel. Thank you. See you in the next one.